What's good for the tap is good for the creek. And this is all part of the premise of kind of program in Pennsylvania and a national program called Source Water Protection. And what we'll be talking about today is the Reading Area Water Authority, which is in central Berks County, and their Source Water Protection Program. And this is one of those programs that brings everything back around 180, 360 degrees, really, because essentially to produce good water for the customers, you need to be making sure that what's going on in the watershed can lead up to that. And the Reading Area Water Authority has been very proactive in making sure that that happens in their watershed. So why is source water protection important? And something that brings this home is a national event that just happened very recently that we're all familiar with, and it was the spill in West Virginia that essentially was a chemical spill that got into the river and affected a number of intakes along that river. They were all surface water intakes. And essentially, there were hundreds of thousands of people without water for 5 days. And actually, if you remember, it lasted longer than that, because even when they started getting the water back through the taps, people were concerned about residuals in the system. Some new things popped up. That was changing, I'd say, daily on an hourly basis. Everything that people were learning. And even to this day, there are still some people who are concerned about residuals within their pipes. So you can see how something like this, one little thing, that if you're not prepared for it, or in this case, even if you are prepared for it at all different kinds of levels, it can still really reach home and affect a lot of people very quickly. So what we want to talk about today is what RAWA, what the Reading Area Water Authority is doing to try to proactively, maybe not prevent these kind of things, prevent them to the extent that they are, but also be able to respond to them on a timely basis in a way that's effective and that's amenable to the public if they should happen. We'll be going over their source water protection plan, some of the management strategies and the implementation that's been going on the last 5 years plus for their source water protection. Then we're going to switch it up and go through a little bit of a technical seminar. I'll be talking about the water quality within the watershed. RAWA has a very extensive water quality monitoring program within the Maiden Creek watershed in this case, which is where they get their water. And finally, we're going to talk very specifically about something called potential sources of contamination within the watershed and what RAWA has been doing in years past and most recently to really be able to understand what these things are that are going on within the watershed, because you got to really understand them before you even know how to react to them. So with that, we're going to switch over to the source water protection plan as part of the presentation, and Jesse is going to give that.
An overview of our system. We serve 125,000 people in the city of Reading and in outside municipalities around the city. Our source is Lake Onalani, which is northwest of Reading. It's 1,082 acres in size, and on any given day it holds 3.9 billion gallons of water, and it has an approximate yield of about 70 million gallons of water coming into the lake. We have a supplemental intake on Maiden Creek below the dam for the lake, which we can use in the event of an emergency in the lake, such as a petroleum hydrocarbon release or any other type of pollution incident. Unfortunately, Lake Onalani is listed on Pennsylvania's list of impaired waterways for phosphorus and for total suspended solids for sediment. I'll talk a little bit about phosphorus in a moment. Source Water Protection Plan, DEP approved it in 2007. We have 2 zones. Zone A, which is here, 63 square miles, and Zone B, 153 square miles. The different zones are established in connection with travel times of water throughout our watershed, a 5-hour and a 25-hour travel time. Our watershed extends up into Lehigh County, so we have 216 square miles that we are responsible for monitoring what comes into the lake itself. On a yearly basis, we get together Actually, we get together more than once annually to talk about different management strategies and ongoing activities on how we can improve and build on things that we've already learned about our watershed. We have an annual steering committee meeting. We actually had it this week at RAWA's office in Reading to bring stakeholders together in the watershed and talk about any concerns or problems that they have, and to also fill them in on what we're doing, what activities we have going on in the watershed. And based on information and feedback that we get, we update our plan as needed. Some of the things that we do, protection on the ground, boots on the ground, however you want to call it. We have a lot of partners that we work with up in the county. Berks County Conservancy is a major partner with us for land preservation and reforestation activities in our watershed. The Water Authority itself every year plants 1,000 trees around the watershed. We have a buffer, a 500-foot buffer around Lake Onawani that we monitor and make sure that trees are growing properly to create a nice riparian edge around the lake. We do water quality and macroinvertebrate sampling throughout the 216 square mile watershed. We'll be talking about that a little bit more in detail as well. And verification of PSOCs, potential sources of contamination. Okay, what do we do on the lake itself? One of the things we monitor for is algae. Like I mentioned before, we have a phosphorus issue in the watershed. There are levels of phosphorus coming into the lake that are higher than they should be. So last year we started an algae sampling program, and what that encompasses is an effort from March, April, May through November of each year. We go out on the lake in a boat and we take water samples at 4 discrete locations, and we monitor the water. We do a Secchi disc evaluation. A Secchi disc, for those of you that don't know, is basically a disc that has, it's like a pie chart on a disc, black and white segments. We literally just throw it over the side of the boat on a rope, and we measure how far down we can see the disc in the water until it disappears from view. We do that to gauge an overall clarity of the water, and we try and trend that information to algae information. Jasmine and MIB, methylisobutanol, these two compounds here are alcohol compounds that are released by algae. And what that does is it causes taste and odor problems in water. So the water samples that we collect, we have them evaluated for jasmine and MIB and different species of algae. And based on that information that we receive, we in turn take measures at the water treatment plant to see if we have to increase our treatment of the water to prevent any taste and water odor problems before the water is released into the distribution system for public consumption. Cryptosporidium sampling. For those of you that might recall, Cryptosporidium is a pathogenic organism that disrupts your digestive system, basically. And in Milwaukee, years ago, there was an outbreak of Cryptosporidium that, unfortunately, it impacted the lives of 400 or 500 people. They were infected with Cryptosporidium. It's a really nasty critter, for lack of a better term at the moment, that you do not want to have present in your water. So we sample for that as well. There's a very specialized sampling protocol that you have to follow. There's really bizarre looking things called cubitaners that you have to fill for the water sample. We've worked with the Philadelphia Water Department a little bit. We're also going to try and partner with them again on some Cryptosporidium sampling throughout the Maiden Creek watershed as well. Fecal coliform sampling, we're also doing that specifically to pinpoint some PSOCs, potential sources of contamination in the watershed. Kind of an upstream, downstream sampling protocol with a suspected target in the middle. So we hope to gain some information about that this year as well. Macroinvertebrate sampling, we do that in order to gauge the overall water quality of health throughout the watershed. We have 12 different locations. I mentioned before that the watershed goes all the way up into Lehigh County near New Tripoli. We have stations set up there that we go out probably once a month on average, and we sample for macros. We do water quality chemistry at the same time. We field identify the macroinvertebrates down to a family level. We don't do genus or species. We're not really set up to do that yet. But just for now, we'll take them to the family level and identify them. And over time, we'll make sure that we have the same type of diversity and the same types of taxa that we have, so that we can make sure that nothing is happening. We're going to give our current locations about another 2 years, and then we're going to switch it up a little bit into different areas within the watershed. To date, fortunately, we have not found, through our macroinvertebrate sample, we have not found any real problems yet. Hope it stays that way. And on top of that, we hope that the water quality gets even better. So, water quality monitoring, again, same thing as the macros. It's used to gauge the overall water quality throughout the watershed. Right now, every Wednesday morning, our guys go out at 10 different locations throughout the watershed, and they sample for temperature, pH, conductivity, dissolved oxygen, and 4 or 5 other things. And once a month, we will also grab samples and have them sampled for nitrates, phosphorus, and total suspended solids. We have accumulated a lot of data right now, and we're working on trying to come up with a geodatabase to start feeding all this data into, so that we and our partners can utilize that information on an as-needed basis. For those of you that probably may have heard, the William Penn Foundation right now has a large Schuylkill River watershed-wide initiative going on right now as well. We are involved in that from the aspect that I am also involved with the William Penn Foundation, so we're going to be exchanging information. The William Penn folks, through the Academy of Natural Sciences and Stroud Water Research Center, want to find out as much about what's happening with water in Berks County. Now, our group, it's called the Middle Schuylkill Cluster, we're charged with documenting impacts from agricultural-related activities. So we're going to be using the information that RAWA has gained over the last few years, and we're going to be using that to supplement the information that the William Penn Foundation is going to be obtaining as well. Sewage treatment plant discharge sampling is a new effort in 2014. Like I mentioned, the lake is on the 303D list of impairment for phosphorus, and this initiative is being undertaken so that we can measure from point source discharges the levels of phosphorus coming into the lake. So we have about 12, maybe 13 or 14 wastewater treatment plants that have NPDES permits. Unfortunately, none of them have phosphorus limits, much to my chagrin. I don't quite understand why DEP has not included phosphorus limitations in their NPDES permits, so we are pursuing that with the department. That's another reason why we're undertaking this initiative. So there are treatment plants that, even though they don't have phosphorus in their permits, they are treating for phosphorus, which is a good thing. There are some, however, that are not treating for phosphorus. And even though in our watershed, the majority of the phosphorus coming into the lake is from agricultural operations, when you add up the point source discharges and the amount of flow that's coming into the watershed every day of the week from people that don't have phosphorus limitations in their permits, it does add up. So we feel that we need to keep an eye on it, and also to keep petitioning DEP to include limits in their permits. We will also be gaining permission before we do this activity from the permittees themselves, so that we can share the results with them. Now, if they come back and tell us that we don't want you to sample our effluent, then we will not sample their effluent. That doesn't mean we can't keep an eye on it, which I fully intend to do. PSOCs, Ashton's going to talk a lot about this in a few minutes. We have a lot of things going on. As you can imagine, 216 square miles is a lot of area, and we have a lot going on in the watershed we'd like to know more about. Unfortunately, we can't be everywhere at once. However, working with Spot Stevens and McCoy, we had developed this big list. There's over 400 PSOCs on this list. There's a lot going on out there. We are like the eyes and ears of the watershed. Unfortunately, we do not have a group that's specifically dedicated to monitoring PSOCs. So RAWA staff, when they're out and about in the watershed, taking samples or doing whatever, they do keep an eye on things, and they do come back and they notify us about things that they have seen, such as a new gas station or a new petroleum terminal or something to that effect. Illegal dump site monitoring is another new effort. We have a lot going on that's new. Basically what we've done is we've taken the Pennsylvania Clean Ways report, which is something that was developed a few years back, which has identified illegal dump sites, I believe, in every county in Pennsylvania. So we took the Berks County portion of it, and I believe there's about 16 sites in our watershed. So those sites are going to be inspected, hopefully, well, found and inspected, and based on their proximity to a stream, we hope to work with either the landowner or the municipality to initiate a cleanup. Part of our source water protection plan that was approved back in 2007, despite all the in addition to all the technical work that we do, there's also a component for education and outreach. This is extremely important to us. It's one thing for us to on a day-to-day basis make sure that the drinking water that the residents in Reading and everybody else gets is clean, and to monitor it. But we also need to spread the word about source water protection, what we do. Our watershed is unique in that Lake Onalani and up gradient from there, the whole Maiden Creek watershed, the people that live in the watershed are not the people that drink the water. The people that live in Reading who drink the water do not live in the watershed. So if you think about it, there's kind of it's disjointed, and it's different from what a lot of other water suppliers have to deal with. So part of our effort is to engage students in schools with information about what we do and why it's important. And even though they're not directly in the watershed and seeing what we do, they are drinking the water, the end product. At the same time, even though the folks that live in the watershed are not getting Reading Area Water Authority water, we need to inform them about our efforts of what we do, because we believe it's important, and we need to solicit their help in keeping all the sources clean. So we have a couple of efforts with the iLead Charter School we're undertaking right now, and Reading Area High School that we hope to get off the ground this year.
I get 2 more schools for you.
Okay. RAWA is also a member of the newly formed Berks County Water and Sewer Association. And what this is, it's a conglomeration of different water suppliers throughout Berks County, and also wastewater treatment plant representatives. And everybody comes together on a monthly basis to discuss different areas that might impact us, like DEP regulations, changing regulations, emergency management. We'll talk about pollution incidents that have happened, contamination issues, continuing education, how can we provide continuing education credits for people, things to that effect. Partnerships with other water suppliers, I can give you an example. Right now, we are partnering with Aqua Pennsylvania to do our algae analysis. Aqua has a very advanced lab in Bryn Mawr, their office. We are taking our water samples for algae and giving it to Aqua to sample. Maiden Creek Watershed Association, just so happens the president is here, Mark, right there. It only makes sense for RAWA to be engaged with the Maiden Creek Watershed Association. It's a dedicated group of people that have come together because they care about what happens in the watershed. RAWA is using the water in the watershed, so it only makes sense that we have a partnership with them. A couple other things, Envirothon, we work with the Berks County Conservation District every year to present awards to kids that have shown an interest in protecting the environment. National Drinking Water Week, we are going to be working with the Berks County Conservancy on removing invasive plants in the Willow Creek watershed And even though Willow Creek comes in below our water treatment plant, it is still in the Maiden Creek watershed. So that's something that even though, you know, the water quality is not really impacted because it doesn't flow into the lake, it still is part of the Maiden Creek watershed associated, the Maiden Creek watershed. So we still want to engage and help with that effort as well. Water supply signs, you've probably all seen these in your travels in and around. Actually, those signs are very hard to get established. Working with, there's two different kinds. There's a sign on state roads that we have to work with PennDOT, and there's a different type of sign that we have to work with local municipalities. The message is the same, the signs are different, are formatted differently. We have, I think, 14 of those throughout the Maiden Creek watershed. I'll talk about emergency management in a moment. And ag restoration, continuously working with the Berks County Conservancy. I'll give a shout out to Larry Lloyd, who is their senior ecologist that Lori and I work with on an almost daily basis. Okay, emergency management. We have had meetings with the Berks County Department of Emergency Services, the Lehigh County Department of Emergency Management Agency to talk about notification. What happens when a truck overturns on Interstate 78 in Greenwich Township? And you have firefighters showing up to put out the blaze or to wash off diesel fuel on Interstate 78. That impacts our watershed. We would like to know about it. Not that we want to impact the way that they do things. We completely understand that emergency responders, the first priority is to protect human lives. However, our initiative here is to make sure that they understand that their actions may affect the water supply. So we're trying to work with them on improving the notification process, because if there's things that RAWA staff can do in the event of being notified that there's an incident, that we would like to do them in order to protect our supply. We have provided, in these meetings, we've provided the Department of Emergency Services with our GIS information so that they have knowledge of what a watershed is. First of all, a lot of them aren't even aware of what a watershed is. Where we stand just geographically, and just to open up the lines of communication, to keep them open. The Delaware Valley Early Warning System is a program that is operated by the Philadelphia Water Department. RAWA staff is is a member of that program. PWD has set it up for notifications as well. And being that Philadelphia is at the bottom of the Schuylkill River watershed, it's prudent for them to know everything that's going on, including in our watershed in Maiden Creek. So kudos to PWD for their efforts. There we go. SAN, Schuylkill Action Network, the ad work group, we're doing a lot of really cool projects with them. And it's kind of the same issues that I've talked about before, working with the Berks Conservancy, the County Conservation District on invasives removals, and on restoring agricultural impacts. We also work with farmers. This is very important for us. We provide every year tens of thousands of dollars to the Berks County Conservancy to support their efforts in working with the farming community to provide them funding so that they in turn can provide it to farmers to implement best management practices on their farms, and also to establish conservation plans. One of the things we did as part of our source water protection program this year is we worked with Rockland Township, and this was a project that we're very proud of. We got some good publicity out of this. Back after Hurricane Sandy last year, there were two huge trees that somehow made it underneath a road crossing in the headwaters of Saucony Creek. Saucony Creek in our watershed. It's a sub-watershed. The headwaters of it have extremely pristine water. The macroinvertebrate sampling there has indicated very pollution-sensitive species. The water quality sampling that we've done indicates excellent, excellent water quality. These trees were caught up on a sand, on an in-stream sandbar in the stream. They were causing sediment deposition in addition to flooding out this yard here. This property was owned by an elderly woman. She had approached Rockland Township before. My yard's getting flooded out because of these trees. Larry Lloyd, again from the Berks County Conservancy, told us about his concern. We mobilized some guys and we got up there and we took the trees out of the stream. So we're basically establishing two things. We were saving this woman's yard from being flooded, while at the same time we were improving the substrate in the stream by not allowing the sediment to be deposited there anymore. So it's kind of a win-win for us, for the people, and also for the environment. So we're very proud of that. And I'll turn it back over to Lori.
So what I'm going to give you now is an overview of some of the water quality monitoring results that the staff of RAWA have collected in the watershed. And as Jesse said, on a weekly basis, they're out there collecting throughout the watershed, which really is above and beyond for a water supply. RAWA recognizes that it doesn't start, the whole protection thing doesn't start at the lake itself. So getting their way down, and I'm going to show you how we've been using this information, because it's one thing to collect it and amass a lot of information, but it's another thing to take it to the next level, figure out if you're doing the right kind of monitoring, apply the correct metrics, and then from there actually make some decisions, maybe some implementation strategies, which we have done. So right now, the watershed monitoring locations that Jesse had mentioned, there's a number of biological monitoring locations. These are the stars. I'm going to be talking about the ones that are pretty much the little circles, okay? And for the most part, what we have is a monitoring location at the mouth of each of the major creeks, kind of coming into the main maiden creek. So the main maiden creek is this backbone right down the middle. So keep that kind of in mind, okay? And each of these other little feeder creeks come in. Oops, that went forward already, but that's all right. The story here is that there's a lot of monitoring going on throughout the watershed. We recognize that. We try to place our locations in places that make sense logistically to find out what's going on, but also to couple results with some of the other groups. And we've, over time, been able to receive information from the Maiden Creek Watershed Association, a little bit of information from Sand and Stroud, and even Borough of Kutztown, Eastern Industries, which is a quarry in that area, we've been able to get some information from them. We've amassed this in a local database, so we keep it locally, and hopefully with the William Penn initiative, we'll be able to take this information. Right now we have just about almost 6 years of information of weekly sampling over and over again, same protocol, same places. So consistency matters, and this program is able to give that for a long-term view. So we got a lot of information. That's the moral story of this graph. I don't necessarily want you to take home any of the numbers on here, except that these are the different things we're sampling for on a weekly basis, and some of them on a monthly basis, because they take grab samples of the last 3 here, okay, and send those out to a lab. The rest, as you notice, are kind of the kinds of things that you're able to collect, with a regular field monitoring device. But the number of measurements over time is staggering at these number of locations. Some of them vary just because the meters weren't working quite right that day. Maybe they weren't able to calibrate something. And we've used that to our advantage to notice when data isn't quite right. Which is important. You have to know when the information coming in makes sense. Sometimes we have pHs that are super high and super low. We look at those right away to figure out, is that really an issue? Because those things could be issues, or was that monitoring equipment failure? And in every case, we looked at that right away and determined, especially in the case of pH, which is a good indicator of just a big change. You may be familiar from water quality. In each of those cases, luckily enough, it was a meter issue that we were able to rectify. And even after one of the incidents, RAWA decided it's just time for a new meter. We need to keep the consistency. We need to be able to have a level of confidence in our data as we're going by. But what's interesting is, I'm going to show you in a second, in some areas how the watersheds are very similar, and in other areas they're not similar at all. I'm going to take a look at phosphate, nitrogen, and total suspended solids first, because those tend to be things that people are most concerned about. And if you remember from earlier in the presentation, phosphorus and total suspended solids are the things that the lake is considered officially impaired for. So that's why we look at them in detail on a regular basis. And it's hard to kind of tell some of the squiggles apart on this trend graph, but that's actually part of the message. The fact that the data there's a lot of data down here really low tells you that things tend to be low values. And I'll show you this in another way in a different graph, since this can't give you the whole flavor, the whole story. But what we are looking for are some of those peaking factors of when we have some issues. Willow Creek, which Jesse mentioned, has some phosphate issues. To orient everyone, Willow Creek is this bottom part right here, okay? It's not the filled-in orange, but it's inside the rest of this dotted line here. And this area has a lot going on in it. There's a number of industrial commercial areas. There's some boroughs in here. And this area has seen development probably 10,000-fold within the last couple of years. It used to be all farms, and now there's probably a new population of 30,000 people in developments where probably, I don't know, maybe 50 years ago it was all farms. So you can imagine the runoff and such coming from that, and we see this in the data. We see that in the data from the residential uses in this area. Same thing, actually, can you just take that back? Remember not to touch the screen. Some of the other things we see that give us a little bit of concern are some of these smaller creeks, the Mill Creek and the Saucony Creek. In this case, these are some of the areas right here around, if you're familiar with Kutztown Borough, kind of all through here, the townships through here. And again, these are areas that do have some population centers in them. So this is something that we're looking more into, and as Jesse noticed, we're actually starting to target these areas because this information at this point is pretty wide. Total suspended solids. In terms of what you should see going on in a lake, or in a stream for that matter, streams obviously would be less, lakes could be more if you had a lot of suspended material, and a lot of the streams tend to kind of trend between 0 and 25 milligrams per liter. But we see these huge spikes, and this is when you see typically muddy water in the streams. Some of the streams are very strong against this. They do not get these huge spikes. But we were able to correlate each of these major spikes and some of the smaller spikes with rain events in the watershed. So what we've learned from here, and it wasn't particularly a new or novel idea, but it supported what they had already found in the TMDL document that EPA did a number of years previous, is that it's these big rain events that actually carry the water into the watershed, and when they do it, it all comes in at once. And ironically, what we see a lot going on in the northern part of the Maiden Creek. You think that that area could potentially be safer up in this more northern part, but what we have going on up here is a lot of these areas, even though right along this stretch here, this is all forested where I'm putting my hands, the rest of this is all farm areas. So there's quite a large volume of solid material sediments which are able to run off during the periods of times during rain events from that. And that's actually not a light problem to be taken because the lake itself is starting to see the sediment pile up. What we're seeing is in the upper parts of the watershed, probably a lot of the larger sediments are falling out, but all the small stuff is being carried all the way down to the lake. And it's probably falling out right where the Maiden Creek proper meets the lake pool itself. And we do see that even in aerial photography over the years. It's amazing to look at it and see these huge piles of sediment in the lake where it used to be open channels going through there. Because of that, RAW was in their first ever planning stages of actually having to dredge the lake because it's become that much of a problem. So dredging is not a cheap endeavor to take. So obviously, There's a lot at stake to doing projects within the watershed that would prevent this sediment from getting there in the first place. Because even a couple projects, you know, $10,000 to $50,000 is a small amount to invest compared to a multi-million-dollar dredging project. And in this case, which will have to be repeated a number of times just to get us back to the baseline of what the lake was when it was put in the 1930s. And again, nitrate trends, you know, this data is messy. It's really hard to look through. But the take home for this that we noticed is, okay, nobody's over 10. That's the drinking water standard. That was the first thing. We say, okay, let's start looking at standards and seeing what we can compare it to. And then the next standard is anything over 5, okay? And so we started looking at the main players who were over 5, and this happens to be 2 creeks called Musselm Creek, and that Willow Creek comes up again. So this creek has a number of issues because of all the development and activities going on within the creek. Let's look at these numbers a little bit, let's look at this data a little bit easier. What I have here is called a box and whisker plot, and it summarizes the data so you can see it all at once. You get the flavor of what's the high, what's the low, where's the midpoints of this data. And so any of these plots, you can see via the legend here that the max value of the first entire 5 years of data. So all 250-ish measurements is all the way up here. The min is all the way down here. So for any one of these plots, it'd be top and bottom. And then this is the middle 50% of the data in the box. And then you can see the line and the little diamond, which correspond to the median and the mean, respectively. So you get the flavor of what's in the middle. For temperature, for the most part, we have some temperatures that go high within the watershed, but most of the data is in a range which we would expect for the range of temperatures throughout the watershed. We do see some of these higher temperature ranges in the northern part of the watershed where the stream is very open. There's not a lot of canopy. It's all agricultural areas, so it does coincide with those kind of land uses. But for the most part, each of these is congruent with the designated use of each of the particular streams. So we were looking down to that level to see, okay, is this like, you know, a big exclamation point going up for those streams? And for none of them it was, except potentially for the northern Maiden Creek. There is concern that we have some of these higher temperature levels in areas that we would hope would support brook trout. In this case, this could be, each of these lines is a particular survival level for brook trout. And so you could have some concerns during some of the seasons of the year. I want you to just look at this over here. When you see something pop up red, that's an area that I have an area of concern. So that little red area is Willow Creek, and we have some issues with pH in Willow Creek. Some of these low points, we actually figured out this low point here, and each of these high points here was meter malfunction. However, Willow Creek does on average have a slightly lower pH than the rest of them. It's still within general, you know, you don't have anything below 6, so it's not a huge concern. We'd more be using pH to see if there was a big contamination event in the watershed. For specific conductivity, this can help us understand how much stuff is within the water. The various ions within the water can conduct electricity from ion to ion within the water, and the more conductance within the water that you have, essentially you can correlate that with more material suspended, or in this case dissolved material being within the water. And you can see there's quite a range of specific conductivity throughout the watershed. And this we found interesting because it does show you that in these cases of these ones that were red, which includes, for example, this creek called the Saucony Creek, which has quite a range. A large range isn't as good for a stream as maybe having a smaller range, because it means that throughout an entire year you really have quite a range of conditions that the biology and such has to endure within that particular water body. This also tells us from our perspective, what's causing that? There has to be particular ions, cations, anions that are causing that. In each of these cases, when we had the high ones, and when they're high, they correlate with the nitrates that were in the water at that particular time. Dissolved oxygen throughout the watershed. We actually have some times when oxygen is really super saturated, which is amazing. We have some saturations in the watershed, and we've checked our meters well over 200%. and to determine that that was correct. And oxygen saturation is a function of temperature. It's also slow to desaturate once you have changing conditions within the water. But that's good for this watershed because it tells us that pretty much it is able to hold oxygen within a wide range of conditions, and conditions relative to kind of other things that are in the water, nitrates and phosphates and such. We've also been able to verify that by looking at another kind of thing called oxidation reduction potential, which is kind of another way to look at oxygen within water. These are the nitrate ranges in the watershed, and just to review, 10 is the drinking water limit, but 5 is kind of a trigger level. So as a water supply, we also look at that as potential trigger levels that we're concerned of. And because of that, we know that the Municipal Creek also and Willow Creek would be potential areas that we would need to attack this problem, because that's where a majority of this would be coming from that would be affecting the drinking water. Total phosphates. Story here, this one's really obvious. So if you haven't been able to follow any of the graphs, you can tell which one has a lot of phosphate within the watershed. And not just a lot of phosphate, but quite a wide variable range depending on the time of year in the Willow Creek. Again, that's this area down here that has just a lot of different things going on within the watershed. But overall, I made things red throughout the watershed to kind of show you some of these areas that do have some peaks within it. So one of the things that I've been showing you throughout the watershed is a lot of the issues that we have actually go on really down close to the lake itself, which is of a concern because if these issues happen close to the lake, there's not as much time for the environment to kind of absorb a lot of these nutrients before they're getting to the lake and resulting in some of the algae issues and such that we've been seeing. Again, this is total suspended solids. This is what's putting all the sediment in the lake. And each of these huge spikes, which go way off the graph, I didn't want to put them there because that would make this data really small and really you wouldn't be able to see it. But they've gone really, really high over time, many, many times over what makes a stream cloudy, essentially, in this area. So when we look at our water quality concerns by targeted watersheds, even if you don't know this area, the take-home message is when we have watersheds that had 1, 2, 3, maybe more of those things that were real issues, I made them red. So essentially that helps us understand which watershed do we get the most bang for the buck in doing the projects within. Helps the water supply side and helps the watershed itself and water quality within the stream. And some of those areas are, like I said, the areas kind of right through here, which is some of the areas which are closest to the lake itself. So what do we do about this? One of the things we've done is we need to pinpoint where some of these problems are happening so that we can actually direct projects right to those problem areas. So one of the things we've done is we've added last year a new sampling location in the upper part of the watershed right in here in this little area called Undeveloped Creek, because we believe that might be where a lot of the sediment particularly is coming from. And also to understand more about maybe point source phosphorus coming in, and because Kutztown is actually being proactive and changed around some of the treatment at their wastewater treatment plant to better take care of this phosphorus. We put in a sampling station there to tell us more about that. And also just more about some cycling within the watershed with manganese, because that's an issue in the water authority side. So with that, we're going to change over to something that's a little bit easier to take in, especially at the end of the day to end it. And Ashton's going to talk a little bit about potential sources of contamination in the watershed. So these are those point sources now that we're going to start targeting, and some of them coupling them with the information that we collected from the various monitoring programs.
I'm going to be talking about more of the technical process that we go through to get how do we find these potential sources of contamination. So basically, as you've sort of probably gotten an idea, we divide our potential sources of contamination into two main categories. They're either non-point source, which you can't really really pinpoint where the contaminant or potential contaminant might be coming from. It's larger areas, agricultural land, industrial land, residential developments, transportation corridors. Those are the main groupings we give them. We also have point sources, things like underground storage tanks, a landfill, a farm with silos and chicken coops. Septic tanks can be an issue. So this is sort of an overview of what we've done this year new for RAWA's source water protection plan. In 2007, they had an inventory made of their point sources of contamination that resulted in, I believe, about 83 potential sources, including areas where transportation corridors, roads, local roads, state roads, railroads cross streams. And this year we found, as Jesse mentioned earlier, 427 potential sources of contamination, and those are just the ones that our databases returned. We also did a land use study which would determine the basic non-point sources of contamination, and that's brand new to RAWA Source Water Protection Plan. When they did the plan in 2007, we did not perform this analysis. So basically, when we pull all of our databases, we have local databases that we use. Most come from EPA, DEP databases. Some others, like the PA Cleanways, illegal dump site surveys. And when we pull it into the map, this is basically what it looks like, sort of confetti with our study area. We clip the data just to our study area and almost look at every single point, try and get rid of as many duplicates as possible. Many of the sites, especially in the industrial areas, will be in more than one database. So we try and condense all of the information into one point per site, which can be very time consuming. This is just a little snippet of what our data looks like at the end when we give it to RAWA and say, you know, these are some of the concerns. This is some of the information that we can provide to you. We have the site name. We provide a PSOC type. So different types include beneficial land use. Those might be farms that use biosolids as fertilizers, water pollution control points, water discharge points. That we have the transportation stream crossings that they did in 2007. And we try and condense all of the information for each point into this comment section, and then we give it a rank. Basically, we rank all our potential sources of contamination from A to F, A being the highest concern, and F being the lowest concern. Now again, that's just a jumping off point for RAWA and their steering committee and the rest of Jesse's team. That way they can go out and prioritize what they really want to concentrate on. And this is just a little snippet of our map. Again, the 427 sites, you can see all 427 on that full-size map over there. You're welcome. We invite you to take a look at all the maps afterwards as well. Sites of particular concern for RAWA's study area include transportation stream crossings, land recycling cleanup sites, storage tank cleanup sites, toxics release inventory sites, illegal dump sites, which Jesse mentioned in detail earlier, and Superfund or surplus sites. Those are the sites that have the worst potential contaminants on site or the highest potential to contaminate. And those are all going to be ranked A, the red triangles on the map. Then we do the non-point source analysis. Basically, we take the study area and cut it up using aerial photography. We just basically trace. We can trace around the lake, around all the farms and the houses, and assign it a land use. I'll go through very shortly each of the different land uses, and it's pretty obvious what the concerns then can be for RAWA to sort of monitor and adjust their management strategies. So agriculture, these are all the orange areas are agricultural areas. This is just for Zone A. We were on a bit of a time constraint for right now. So the agricultural areas in Zone A comprise almost half of the area. They're all ranked B, so pretty high area of concern, and that's evident in the data that Lori presented as well. Residential is about 15% of the area. That's all ranked C. It includes possible contaminants. People don't really think about what they spray on their lawn for lawn care. Fertilizers in gardening, stormwater runoff is a huge one, and even the motor oil from vehicles, household vehicles. Industrial and commercial sites, this is sort of our grab bag. This will be anything from schools and government buildings to big industrial sites and energy plants. Anything that really doesn't fit in another category. That's why we have such a wide range of rankings for this area, and that's about 5%. Now, looking at this, Rawa can go in and ask us, you know, what are these orange areas? What are these blue areas? We have a database for them to look at that and see where they want to prioritize going out and verifying these locations. And then transportation, this is our highest concern, especially where the transportation corridors cross the streams. Mostly they're ranked A, except for the pipeline is yellow down here, and the railroad, which is orange. And transportation will include local roads, state roads, railroads, and pipelines. And then these are all our undeveloped areas, our forests, our waters, streams, and lakes. We don't rank them since they're not developed, but obviously they have some sedimentation issues. If there's any logging or any activities in the water, there could be some issues. But that can be determined how they would like to manage that with the water system. And then we have just a couple minutes for questions if you all had any.
That's right, because we did start late.
Okay.
So,
You guys have any questions?
I have
Any of
a
us?
fundamental water quality question that maybe a lot of the folks already know what it is. But when you're looking at the temperature of the upstream, I know how that can affect the ecology there, but how does that affect drinking water? How does water temperature affect drinking water? Do you understand my question?
So literally when they're withdrawing it, usually the upstream temperature itself will not affect the particular temperature where they take the water in, where they withdraw it. Because by then it's already gone to the lake, it's mixed, and now it's subject to other issues. The lake itself has issues with mixing or with the lake having different thermoclines, meaning different temperature regimes as you go throughout the lake. In terms of the actual temperature, it could affect it on the end when they add different chemicals into it. There's some chemicals that go in right when they pull the water out of the lake. There's chemicals that go in at the end, and some of them are required by the regulations. I'm not familiar, and maybe Jesse can answer a little bit more about Rawa's process. It's very particular to that individual treatment plant.
The two things that I think of immediately with temperature with respect to water, number one are algae, formation of algae. In the summertime, since our intake is on the lake, in the summertime, when we don't have a whole lot of water coming in, it's basically a big bathtub. It sits and it bakes, and that forms algae. It gets with the phosphorus coming in, there's a lot of eutrophication that occurs. Algae love that, and they bloom and they blossom and they go nuts. That in itself is a big problem for us because that is additional suspended solid material in addition to the possible taste and odor problems that we have. So temperature, that's a direct consequence there as well. Chlorine, which we use to disinfect the water before it goes into the distribution system, it reacts differently in cold water than it does with warm water. We actually add ammonia to our final water that leaves the plant because chlorine can bind with ammonia and it stays with the ammonia longer. So we add it to hold the chlorine in place as it moves throughout the distribution system to people's taps so that we have it. But if we weren't adding the ammonia, we have found that a colder water versus a warmer water will hold chlorine differently. So,
Okay, thank you.
Julie?
How receptive have been the municipalities to things like stream buffers and, trying to reduce some of that sediment and erosion issue and the phosphorus, all that coming off your lawns and so on?
unfortunately, not very receptive. We're trying very hard to engage municipalities. I mean, we're dealing with some municipalities in our watershed that don't have websites.
Right.
And we have to go through the county to get a lot of municipal information. And we find that in some instances, the municipal information that we're getting is 10 years old. So it's difficult. We are really relying on the Berks County Conservancy and the County Conservation District to help us with that. But quite honestly, it's difficult. I mean, those guys are out all the time, boots on the ground. They're identifying problem sites everywhere with specific farmers. But municipalities in general they're difficult. It's a challenge.
Yeah.
And there's been a large effort to even more recently to invite them to a number of the events and try to get them involved, especially with the steering committee meetings and such. And slowly but surely, we're seeing a little bit more involved. We're seeing the light bulbs go off. But yeah, it's definitely a slow process. So, you go back to your municipal representatives, let them know this kind of stuff is important to you. They really need to hear that from their constituents. Because often these connections aren't being made. They're very busy people. Often they have other jobs. And they're doing that on the side. And so it's been a hard go, a slow go, very small baby steps.
Also, I wanted to just bring up one last thing, and it has to do with Willow Creek. And I know Lori and I and Ashton both referenced it a lot. And Willow Creek is a really bizarre watershed. We kind of noted in our presentation that there's a lot of problems going on in Willow Creek. There's high phosphorus, the conductivity is not where it should be. It's had a lot of development through it within the last 10 years or so. Those are issues, and we're seeing it with respect to the water quality. But the flip side of that is Willow Creek is one of the few Class A brook trout streams that we have in the Willow Creek watershed. So here you have a Class A brook trout stream that holds a viable population of reproducing brook trout, yet the water quality is not what it should be. And if you go and we've assessed the macroinvertebrates in that stream, they're horrible. What we found is very pollution tolerant organisms. So immediately you would think, well, how can that be? How can you have a stream that sustains brook trout, yet at the same time have the benthic aquatic community be horrible and the water quality be marginal? So, it's just all these different factors that come together to form different areas within the watershed that you have different parameters that you need to look for. And trout are happy in one certain little segment that has a lot of streamside buffers and riparian areas that are partially forested, yet in other areas you won't find them. So in my mind, that makes it really unique that we have that in our watershed. It's very different than what we usually find.